Okay, so welcome to our 17th class. I think 17th or 18th class of our 1 minute. I think it is 17th or 18th. Okay, whatever it may be. So welcome to our class of computer architecture and organization. So in this class, we are going to discuss about the concepts called stack and queue. Okay, in this class, we are going to discuss about the concepts called stack and queue. Okay, before discussing about what is meant by stack and what is meant by queue, once again, I will just remind you the last class. Okay, so once if you observe the concepts what we have discussed in the last class is we have discussed the concepts called subprogram or subroutine in our last class, isn't it or not? So in our last class we have discussed the concept called subprogram or subroutine. What is meant by a subprogram or subroutine? It is nothing but a subprogram is nothing but a small part of a so a subprogram is nothing but a small part of a program that is written separately from the main program. That's what we have discussed in the last class. Now, a subprogram is a small part of the program. Actually, it is not written in the main program. It is written separately from the main program. So it will be referred as subprogram. Okay. And while discussing this example, I have told that see, whenever we are having two important instructions called call and return, along with those instructions we have discussed a little bit about two more instructions called push and pop, isn't it or not? So in this class we are going to discuss in depth or in detail about this push and pop operations. Okay, so while explaining this particular figure or this particular diagram, what I have showed you in the last class, see what I have explained, whenever we encounter or whenever the processor or controller encounters call instruction, then obviously we used to write a call space name of the subroutine or subprogram. Okay, whenever our processor will come across this call instruction, then automatically it will transfer its execution or it will skip its execution to this particular subroutine which is written. Okay, subroutine name may be, for example, if I write some addition as the name of a subroutine, then automatically my controller will transfer from here to the name of a subroutine that is present here. Okay, and it used to execute all the instructions like this. We have explained in the previous class. While explaining this, I have mentioned you one thing, that see, I or you, we all are humans, we have common sense. I have at least a minimum common sense. I don't say I have much more, but I have a little bit of common sense. So I am aware. That means, for example, if I want to come from Tenali to the college every day, okay, so as I'm a human, I have some common sense. I know the route to be traveled. Okay, I know that route to be traveled. Okay, I know the starting point and the ending point. So when I start from my home, it is the starting point, and my destination is the college. Okay, and I used to do some work like recording the videos, preparing the quiz examinations, or preparing some notes for me. Okay, or preparing some subject or whatever it may be. Again, when it's when the college timings are over, then I used to come out from the college and I will just come to my home. In between, if my parents or my family members, if they tell me to take some vegetables or something, I will bring those vegetables and everything. I am a human, and finally where I am going to reach, I will reach my home, isn't it or not? I will start my from my home, I will go to my college, do my work, and I will again return to my home. Okay, because I am a human, I have common sense. You are also humans, you have also common sense. You will come to the college, you will start from your home, you will take an auto or college bus, whatever it may be, and you will come to the home, you will do your work, again you will go from here to your home. Okay, isn't it or not? So as we are having some common sense, we know what to do, but computer is not having any common sense, isn't it or not? So see here, what I am trying to say is, whenever there is a call instruction, then automatically the controller will transfer from main program to this what you will call subprogram or subroutine. Okay, it is very fine, because I have mentioned the name of the subroutine here. So it will search where that particular subroutine is, and it will reach to that particular subroutine. Okay, it is well and good up to now. But the problem is, whenever it encounters the return instruction, it has to return to the original main memory. That too, the next instruction in the original main memory from where it has skipped, isn't it or not? Previous it has skipped from the main memory from this instruction. Okay, after executing all these instructions, it should now shift to the next instruction. Okay, how come this computer comes to know? Because as we are humans, we have common sense. Computer don't have any common sense, no? Then how can the computer knows that it has to skip to this particular instruction address? For that purpose, we are going to use a concept called stack. We are going to use a concept called stack. The main purpose of using the stack is, in our programming, the main purpose of using the stack is whenever we encounter these kind of subroutines or subprograms. Whenever we encounter the subroutines or subprograms. So what this stack is going to do? Stack is a temporary data storage device. Stack is a data storage device. Okay then. Next, what it will do? See, it will help you to see once if the controller skips from main program to some subroutine or subprogram, then what it is going to do means our main program, our controller or processor, it will store the address of the next location to be executed in the main memory. The address, for example, if it is transferring from this instruction, then it will store the address of the next instruction which is to be executed once the subroutine execution is over. Okay, it used to store it used to store the address of the next instruction to be executed. That is the first one. Second one, it used to store the contents of the flag registers. That means you may have zero flag, carry flag, auxiliary carry. Those all things you will understand in the next units. Okay, no bother. Okay, so don't bother. So it used to store the flag register status, next address status, segment address, like this. All these things will be stored in the stack. All these things will be stored in the stack. Okay. Once once the particular subroutine completed the return instruction, then what it is going to do? It will again come. It has to come to the next instruction in the main memory from where it has transferred. Isn't it or not? How come this will come to the next instruction? You don't know. Okay. Then first of all, what is the thing that is going to happen means this particular controller, it will, whenever it encounters a return instruction, it will return to the stack, but not to the main program immediately. Okay, in stack it will pop the values that was stored. Previously it has pushed the data. Now it will retrieve the data. Retrieve means removing the data from the stack. That operation is called pop operation. Inserting the data into the stack is called push operation. Okay, that we are going to discuss now. Okay, so it will again go to the stack. There it will retrieve the data and it will see, okay, I have came from so and so address, so my task is to go to the next address. Like that it will think and it will come to the next address. This is the way the stack is very much useful for subprograms or subroutines. Okay, now we are going to discuss about that particular stack. Okay, in depth. See, what is a stack? A stack is a computer program often needs to perform a particular subtask using the, first of all, what they are going to discuss means the first point is entirely about subroutines or subprograms. What we have discussed. Subprograms are nothing but they are the small part of the programs. They are written separately from the main program. They are small part of the programs. They are written separately from the main program. Okay. So in the next point, what they are going to discuss, a computer needs to control, organize information linkage between main program and subroutine. That's what we have discussed in this picture. A computer needs to, it needs to control and organize the continuity flow of data between the main program and subprogram. That means there may be n number of subroutines or subprograms. The main a computer or the processor needs to go from main program to subprogram. It needs to execute those things. Again, it should come to the main program. Later on, if there is another subprogram, it needs to go from the main program to that particular subroutine. It needs to execute all the instructions. Again, it has to come to the main program. So these kind of things should be taken place continuously. Okay, a computer needs to control, organize information linkage. That means exchanging of information between main program and subroutine. So there should be an information linkage between the main program and subprogram. Okay, to do this we will go for a stack. So in order to maintain the information linkage without any linkage problem, we will use a concept called stack. How come this stack is useful? See, what is meant by stack? See, stack is a list of data elements. Usually a stack consists bytes or words. Words are also multiples of bytes. That means word size may be 16-bit or 32-bit. Sometimes the word size may be 64 bits. Whether it is 8 or 16 or 32 or 64, it will be a multiple of bytes. Byte means 8 bits, isn't it or not? If the word size is 16-bit, what does it mean? It is nothing but 2 bytes. If the word size is 32-bit, it is nothing but 4 bytes. If the word size is 64, it is nothing but 8 bytes. Isn't it or not? Okay. So here, what is the stack means? Stack is nothing but a temporary data storage device. It is opened only at one end and closed at the other end. See, the picture of stack will be like this. Okay. Here, one end will be used to be closed. It is like just like the things what you will place the CD stand, where you used to place the CDs one by one like this. Okay. So here, stack is nothing but it is just like a device where one end is closed and the other one is only one end is open. That means whether you want to insert the data or to retrieve the data, you may perform by using only one end. The other end is closed permanently. Okay, మనకు డబ్బా లాంటిది. ఓకేనా? ఆ డబ్బాలో మీరు బిస్కెట్లో బూరెలో అయ్యో వేసుకున్నాను అనుకోండి, ఏమైంది? మనం ఎంత వేయాలన్నా పైనుండే వేయాలి, తీసుకోవాలన్నా పైనుండే తీసుకోవాలి. బికాస్ స్టాక్ ఈజ్ a device or it is an element where one end is completely closed. ఒక జార్ లాంటిది, ఒక డబ్బా లాంటిది అన్నమాట. కింద క్లోజ్ అయిపోయి ఉండిద్ది. మీరు కొత్తగా ఎలిమెంట్స్ యాడ్ చేయాలన్నా పైన యాడ్ చేయాలి, తీయాలన్నా పైనుండే తీయాలి. ఓకే, the elements may be inserted or deleted only from the one end, that is also from the top end. Okay, here in this diagram you can see two instructions that are present here. One is push operation and the other one is pop. Here if you observe the arrow mark, pushing means something inserting the data into this particular stack. That means if you are adding some elements into this stack, okay, that phenomena is called push operation. Here also you can easily observe that whenever I am performing this push operation, the data elements are going to be inserting. You can observe this arrow mark. Here we are adding the elements or putting the elements into the stack. This phenomena is called push operation. Okay, so what is the thing that is going to happen in the push operation? See, stack follows an order called Lifo. Here you can observe LIFO. This is the order of stack. What is the full form of Lifo? Lifo stands for last in first out. What does it mean? Last in first out. That means the element which entered last is going to be taken first. Example, consider these things as the sum your what you will call అయ్యో గారెలు లేకపోతే సంక్రాంతికి చేస్తారు కదా వాటిని అరిసెలు. Okay, consider them as some food items like అరిసెలు. Okay, see if you observe, you are inserting those things in a box. సంక్రాంతికి బాగా చేసుకున్నాం, ఒక బాక్స్ లో పెట్టుకున్నాం. ఓకేనా? పెట్టేటప్పుడు ఎలా పెట్టుకుంటాము? ఫస్ట్ నీకు ఏదైతే అరిసెలు తీసుకొని నువ్వు పెట్టావో అది ఎక్కడికి వెళ్ళిపోయింది? బాక్స్ లో కిందకి వెళ్ళిపోయింది. అవునా? నెక్స్ట్ పెట్టిన అరిసె ఎక్కడికి వచ్చింది? పైకి వచ్చింది. అవునా? దాని తర్వాత ఇంకొక అరిసె పెట్టావు, అది ఇంకో పైకి వస్తుంది. ఓకేనా? దాని తర్వాత పెట్టింది ఇంకా పైకి. ఇట్లా మనకి ఏంటంటే ఏదైతే చివర్లో ప్లేస్ చేసావో అది ఎక్కడ ఉండిద్ది? ఎప్పుడు కూడా టాప్ లో ఉండిద్ది. The same phenomena is being performed in the stack also. Stack follows an order called Lifo. Lifo stands for last in first out. That means మీరు అరిసెలు పేర్చేటప్పుడు కూడా ఫస్ట్ లో పెట్టిన అరిసెలు చివర్లో వెళ్ళిపోయింది, దాని తర్వాత పెట్టింది దానిపైన, దాని తర్వాత పైన, అలా చివర్లో నువ్వు ఏదైతే అరిసి పెట్టావో అది ఎలా ఉండిద్ది? అన్నిటికన్నా టాప్ మోస్ట్ లో ఉండిద్ది. ఓకేనా? ఇప్పుడు నువ్వు తీసేస్తున్నావు అంటే తిన్నావు అనుకున్నాం, అరిసెలు చేసుకున్నారు, నీట్ గా పెద్ద బాక్స్ లో పెట్టుకున్నారు, పక్కన పెట్టుకున్నారు. ఓకే, మళ్ళీ ఇక్కడ నువ్వు పెట్టిన బాక్స్ సైజ్ లో ఒక్క అరిసె మాత్రమే పెట్టింది, దాన్ని పక్కన పెట్టొచ్చుగా, వెనక పెట్టొచ్చుగా అనొద్దు. నువ్వు చిన్న డబ్బా, సన్నగా ఉండే డబ్బాలో పెట్టుకున్నావు, ఒక్క దానిలో ఒక్క అరిసె మాత్రమే పట్టింది. ఓకేనా? ఇప్పుడు నీట్ గా ఒక 50 అరిసెలు చేసుకున్నావు, ఆ బాక్స్ పెట్టేసావు. ఈవినింగ్ అయింది, స్నాక్స్ తినాలన్నప్పుడు వెళ్ళావు, ఒక అరిసె తీసుకున్నప్పుడు ఏ అరిసె వచ్చింది? మనం ఏదైతే చివర్లో పెట్టామో, ఫస్ట్ లో నువ్వు పెట్టిన అరిసి ఆడికి వెళ్ళిపోయింది, కిందకి వెళ్ళిపోయింది. నువ్వు చివర్లో ఏదైతే అరిసి పెట్టావో అది పైకి వచ్చింది. సో నువ్వు తీసుకునేటప్పుడు వచ్చే అరిసి ఏంది అంటే, చివర్లో నువ్వు ఏదైతే అరిసి ఆ బాక్స్ లో పెట్టావో అదే వచ్చింది. దట్ ఫినామినా ఇస్ కాల్డ్ లిఫో, లాస్ట్ ఇన్ ఫస్ట్ అవుట్. నువ్వు చివర్లో పెట్టిన అరిసినే ఫస్ట్ బయటికి తీసుకొస్తున్నావు. Okay, this concept is followed in stack, because stack is closed at one end, so there is no possibility of getting out from this end. The only one lead that is open is front end. Okay, so the elements that are near to the front end, those will be escaped first. Okay, that's what they are going to mention here. Okay, so what is meant by push operation? Push operation is nothing but inserting the data into this stack. Inserting the data into the stack is called push operation. Deleting or retrieving or removing the data, retrieving, deleting, removing, whatever, these three things are same as far as stack is concerned. Retrieving the data, removing the data, or deleting the data from the stack is called pop operation. So we are having two operations, push and pop. Push operation is nothing but inserting the data into the stack. Pop operation means retrieving or removing or deleting the data from the stack is referred as a pop operation. So in a stack we are having these two operations. Stack follows an order called Lifo, L-I-F-O. Lifo stands for last in first out. Lifo stands for last in first out. That means the element that is inserted last is going to be retrieved first, just like our Arisal example. Okay na? Next, here you need to discuss about one more thing called stack pointer. What does it mean? Stack pointer. So stack pointer, what is the mean by stack pointer? Stack pointer is one that always presents at the top of the stack. Top of the stack. That means, see, if I, for example, I have inserted 1 2 3 4 5 6 elements, consider 6 arises. Okay, then the stack pointer will be always at the 6th position. Okay, whenever I insert one more arisa, then the stack pointer will move from 6th position to 7th position. Okay, because it is the top element. Whenever I insert 8th arisa, then the position of the stack pointer will be from 7th position to 8th position. That means whatever the highest value or topest value that is present, the stack pointer uses to shift to that particular position. For example, if I have only 2 arisas, the stack pointer will present in the 2nd position because it is the highest position. Whenever I insert 3rd one, the stack pointer will move to the 3rd position. Whenever I inserted 4th one, the stack pointer will place in the 4th position. That means stack pointer will always be present at the top of the stack. Will always present at the top of the stack. That is the thing you need to remember. Okay, so what it is going to do is, it is going to push all the values to the down and it will always be in the top position. Okay, అంటే ఎలాగా అంటే బట్టలు కుక్కుతా ఉంటాం చూసారా, మనం ఎక్కువ ఎక్కడికైనా ఊరికి వెళ్ళినప్పుడు చాలా బట్టలు పెట్టాలనుకోండి, పైన పెట్టిన దాన్ని కుక్కుతా ఉండి మనం చేతితో కుక్కుతా ఉంటాం కదా. సో దట్ ఈస్ ద కాన్సెప్ట్ హియర్ ఆల్సో. So overall, what is the information you need to know about the stack is, stack is a data storage element. Generally, the main purpose of the stack is in subroutines or subprograms. Stack follows the phenomena called Lifo, L-I-F-O. Lifo means last in first out. Stack has one end closed and one end only opened. That means if you want to insert the data into the stack, or if you want to remove the data from the stack, you need to do only from that particular open end, because one end is closed completely. Next, there are two important operations we can perform on the stack. One is push operation and the other one is pop operation. Push operation is nothing but inserting the data into the stack. Inserting the data into the stack is called push operation. Retrieving or removing the data from the stack is called pop operation. So these two are the important operations. And we are having stack pointer. What does it mean? Stack pointer. The stack pointer will always present at the top of the stack. Where it is going to present? It is going to present at the top of the stack. These are the things you need to remember about the stack. Stack follows Lifo order. Last in, first out. That means whatever the element that is inserted last, it is going to be picked first. Okay. So again, this is a small example. See what is mean by push operation. For example, initially I have stack having only one value, that is 1. Now I inserted a new value. Push space I have given some value. See, whenever I perform push operation, this 2 is going to be placed with it is placed top of the 1, isn't it or not? Whenever I am trying to insert the new value called 3, it is placed above the 2. 4 is placed above the 3. 5 is placed above the 4. 6 is placed above the 5, isn't it or not? So these things are push operations. Okay. Now observe the pop operation. See, once if you observe this example, what is the last element that is inserted? 6, na? Okay. Before 6, what is the last element? 5 being inserted. Before that, 4. So among all these things, the last element that is inserted is 6. The last element that is inserted is 6. Isn't it or not? Yeah. So now for this, we are going to discuss about pop operation. As I have told you previously, pop is nothing but removing the data. Here, push means inserting the data. Here you can observe a new element has been introduced into the stack. Another new element, another new, another new. The previous elements are as usual and the new elements are going to be inserted. This phenomena is called push operation. And once if you observe the pop operation, what is the thing that is going to happen? That is the pop is the reverse operation of push. Pop is the reverse operation of push. If you observe carefully, you can draw the diagrams of pop from this side to this side, just interchanging the arrow marks. This diagram appeared here, this diagram appeared here, this appeared here, this appeared here, this appeared here. Just arrow marks are interchanged. That is the only thing. That means what is the thing that is going to happen? Whenever I perform a pop operation, the data that was inserted last, that means 6 is there now, it is going to be retrieved first. Next, what is the topmost element? 5. That is going to be retrieved in the second cycle. Next, what is the topmost element? 4. That is retrieved from the third, retrieved when we are performing the third operation. So this is about push and pop operations. I hope you all understood very well. Okay. So that is the matter I have included in my topic also. Push and pop. So generally stack is a list of data elements. The data elements may be bytes or words. That means if you want either to push the data or to pop the data, you cannot push 3 bits, 5 bits, 4 bits, 10 bits like that. If you want to push, you need to push either at least 8 bits or multiples of 8 bits. That means either 16 bits, 24 bits, 32 bits, 64 bits like that. Okay, you cannot push 4 bits, 10 bits, 12 bits, 14 bits like that. Similarly, whenever you are popping the data, that means whenever you are removing or retrieving the data, then also you have to follow the order of bit or word order. That means you cannot remove 2 bits, 4 bits, 10 bits like that. If you want to remove, you can remove at least 8 bits or multiples of 8, like 16 or 32. 24 is also not possible. 32, 64 like that. Okay. So that is about this one. Next, stack. Here you can observe that the elements can be added or removed only at one end. That's what I have discussed now. In stack, only one end is open where you can either insert the data. Adding the elements is called insertion. Removing the elements are called deletion. So for insertion, you will go for push operation. For deletion, you will go for a pop operation. Okay. Next, so it will be stack is always top of the stack. Only stack pointer is there now. That will be present at the top of the stack. The insertion or deletion is possible only at the top of the stack. The bottom of the stack is closed. So that's what I have presented in this diagram. The bottom of the stack is closed permanently. Either insertion or deletion is possible only at the top of the stack. That's what that was given in the diagram. And we are having majorly 2 operations. One is push operation and the other one is pop operation. Push is nothing but inserting the data into the stack, whereas pop is nothing but removing or retrieving or deleting the data from the stack. So, and one more thing I have discussed, the stack pointer. Stack pointer is nothing but it is always present at the top of the stack. The purpose of a stack pointer is point us always. I think you have got this concept called point us in your C program. What is a pointer? A pointer is one that always points towards the address in the memory. A pointer is one that always points towards the address in the memory. Here also, stack pointer will always present at the top of the stack. It always points the address, top address, but not the value. Okay, it always points the top address of the stack. Okay, so that is about the stack pointer. Okay, so this is about stacks. In the next class, we are going to discuss about queues. Okay, thank you.